Very good evening, Shrivedhan. Good evening, sir. Good evening, Lakshmi. Okay, so let's just continue with the class. I guess everyone has joined now already. Okay, so let's continue. So, first of all, wishing you very good evening, everyone. It's going to be our fourth session on the same chapter, that is aldehyde, ketone, and carboxylic acid. So, let me just quickly give you a brief in the previous class what we just discussed there, right? If you remember in the previous class, we discussed about the ketone. Okay, and in ketone part, okay, we discussed about two kind of reaction. The one, wait, I will explain what is that. So, what was the last topic? That basically we're discussing about the preparation of the ketone there. Okay, so in the preparation part we discuss about some reaction there. If you remember, that is one is this the cadmium one. Okay, if you remember, CdR2 there. Okay, and then with the help of this we are forming a ketone. Okay, so this is all for the previous class kind of. So let's continue with the today's class. So in today's class, what we are going to start, that the chemical reaction of aldehyde and ketone. Okay, so in this part we are going to start with the nucleophilic addition reaction there. Okay, so as the name suggests, what we are going to do basically, that we are going to add the nucleophile. For example, like we are discussing about aldehyde and ketone, both the part here. Okay, so let me just take some general part. Like what if I'm having, this is the COH. Okay, this is a normal part here. So in this case, what is happening, that if you are having some kind of nucleophile, everyone you know that in this case, this one has a partial negative charge and this one has a partial positive charge. So definitely nucleophile, sorry, positive. Definitely the nucleophile is going to attack on this carbon here. Why? Because this is a positively charged symbol. Okay, so it means this carbon is a kind of electrophilic center, and that's why the nucleophile is going to attack here. Okay, so let's just start with the very first part, that like nucleophilic addition reaction there. So if you're observing, it's a kind of mechanism. Let me just write the name. It's a nucleophilic addition reaction. Okay. So yes, observe please. So what is happening? If you are observing something, look at this nucleophile here. So what is happening? Nucleophile attack here, this bond open up, and now you have to remember the mechanism, because every time we are going to follow the same mechanism. Very good, Harika. Okay, so it's really much important mechanism, you can say. Okay. So let's just back again that okay. So look at this nucleophile and this O negative generated, and then this O is going to extract some hydrogen, and this group is basically going to generate. It means with respect to some nucleophile, every time some OH group is going to combine. Okay then, so let's start. Let's observe this first reaction there. There's a so many reactions. Reaction number one, that if you are having HCN, okay, again mechanism is not really important here. Try to understand the point, actually how it is going to work. This is a cyanide, negative ion, right? Although it's not a ionic bond, but still just observe that this one has a partial positive charge and this one has a partial negative charge. It means Cn has a negative charge simply. Okay, so this Cn is going to attack here. It's being like a nucleophile simply, and this is how the bond open up. So what we're getting in this case, if you have to proceed with the reaction, that it's a CH3 simply. Okay, and since this bond open up, so it's a negatively charged, and this is a Cn. and hydrogen is there. And the second step that undergo the hydrolysis one, that H positive. So what is happening now, that CH3CO H and hydrogen and CN form there. So this is a first type there. As the name, what is it? It's a acetyl cyanohydrine. Okay, yes, the name is very important here. Maybe it seem like it's not important, but it's really very much important part of the biochemistry topic, like acetyl cyanohydrine. So acetyl be like, why? Because there's a two carbon there, so that's why the name become acetyl. Okay, and why the name is cyanohydrin? Because cyanide group is connected and one hydrogen is connected. So the the cyano group, so this is known as a cyanohydrin. So you can remember in this way. Okay, maybe my video blocking your path. Let me just change it. Okay, observe this now. So this is a acetyl cyanohydrin. Okay, I hope the mechanism is clear for everyone. Okay, if mechanism is not clear, let me know. Otherwise, it's not all, that's not very much important here. Okay, let's see one more type. All are the example of the nucleophilic addition reaction. Okay, so observe this one more here, that if you're observing, this is aldehyde and ketone both can be there, and OH. Okay, I hope you know that in this case are O negative and H positive, like this is the case. Again, it's not a ionic bond. This is the thing is totally wrong, I know. Okay, but still just try to understand the mechanism, how it is going to work. This is a O negative, simply attack here, this bond open up, and let me just write here that it's a carbon and a O negative generated, and this OH part is going to combine like this RO. Okay, and then further that hydrolysis is there, and then what we're getting, that this thing what is written here. Now what is the important here? The name is really important. It's known as a hemiacetal. Do you know the name, like why the hemi? Because in this case only one OR group is connected. If let's suppose, okay, this is just like a kind of information for you, we are going to discuss again about this. If let's suppose in this case both group is replaced by the OR is there, okay, like this, if this is the case, so it's become acetyl only. Acetyl. What is the meaning of hemiacetal? That when one portion is OR, it's not fully that one portion only, so it's become hemiacetal. Okay, so name is really much important here. This is all for the, you can say the point number one, that kind of nucleophilic addition reaction. Okay, so let me just give you explain one more reaction there. Okay, so let's see one more. Okay, same R, I'm sorry, same R, COH we are having. Okay, aldehyde ketone, you can take anything. Okay, this side, let's suppose in this case I'm using NaHSO3. Okay, NHSO3, then what is going to happen? Who is going to add here? Like Na part is going to add or HSO3 is going to add. So like good point, that it's a kind of ionic, it's a partial positive charge, it's a partial negative charge. So if I have to write the general reaction, so what we are end up again, that similarly uh, kind of hydrolysis. Look at this. So what is happening then? This is a OH, and this side, this time that it's replaced by SO3H is there. Okay, I hope you got my point. Actually, am I explaining here that every time whatever with this O become OH and any nucleophile simply connected here. Okay, so this is a kind of nucleophilic addition reaction. Okay, that's it. This is all for the nucleophilic addition reaction there. So let's just back again what we're discussing. Okay, so this part is done. Now let's talk about the point number two, that is the reduction one. Okay, so when this point again come, reduction. So we already covered a little bit about the reduction, lithium aluminum hydride, sodium borohydride, diballage. Reduction part main we already covered. But since now we are talking about both the cases, so let's see how it is going to affect. Okay, so let's just start with the reduction part. And in the reduction part, observe that the total three kind of reduction we are going to deal now. That one is the Clemenson reduction there, then the Wolff-Kissner reduction. Both are almost same. What is important? What is the important key point we are going to remember? That for Clemenson reaction, we are using acidic condition. We are going to use acid. But on the other hand, for the Wolff-Kissner one, the basic condition, the acidic and basic condition is the only point that differ these. Otherwise, the like reaction, everything is going to be almost same. And the last one is the Wittig reaction. It's different, like as compared to the Clemenson and Wolff-Kissner there. So let's just start with the point number one, that is a Clemenson reduction there. So in this case, as we already discussed, we are going to use some kind of acids. Okay, let's see how we are going to use some kind of acid there. So observe that this is general reaction. We are using zinc and Hz. Okay, zinc and Hg in the presence of HCl. HCl, acid, acid, acid. I'm repeating again and again. So how it is going to work simply that in this case, mechanism important? No, mechanism we are not going to deal. Simply what is happening, whatever with the CO group. This is the only kind of reduction. Like right now we're discussing if a CO group may be the alkyl form. But in this case, what is the key point? That this is replaced by the two hydrogen. Yes, that hydrogen is going to add and going to replace the oxygen there and water molecule remove. Okay, so let's see how about the like kind of thing how to remember this. Okay, so let's just discuss about how, this like how it is going to work. So you will be having some R. Let me just write like this, that this is a CO O, okay, and water HCl basically we're using, right? So in this case, let me completely write the reaction zinc, mercury, and HCl there. Okay, so what is happening in this case? That water molecule going to release. Okay, so in this case, that is a two. This part is combined with this hydrogen molecule is going to release. Sorry, water. I'm sorry. So and then that some hydrogen is combined here. So be noted that in this case, two hydrogen added and plus that water molecule is going to leave. So let's just back again. This is all for the point. Now, the second point, the knot. Look at this point, the yellow one. You know what is this? That due to the presence of acidic conditions, zinc acid elimination reduction, we are not going to use. Not getting? I'm also not getting. What is this? Okay. So what is the point to be noted here? This is an acidic reaction. It means we are using acid there. For example, just try to observe that. Look at this. Okay, it's a kind of point. This is my OH. Okay, and let's suppose this is my CO, and I'm using the same thing, that is Zn, Hz, and HCl there. So I know one thing, it's a Clemmensen reduction, right? So what will be the expected product? The expected product, like okay, it is going to reduce. So simply no need to represent it. It is neutral there and OH. This is the expected product which we want. But what is the problem? It still be like I'm having H positive and this is OH and everyone you know oxygen has a lone pair. So what is happening that as compared to this reaction, first of all this reaction is going to happen. As I already told you, this is the rule of the chemistry. If there's a possibility of acid base reaction, that reaction is going to occur first. So what is it? It's a kind of acid sensitive. Okay, it's an acid sensitive group. It's simply a acid sensitive group. It means it is not good for this type of reaction. No, it's not good. So let's just back and now read the statement. What does the statement want to highlight? That due to the presence of acidic conditions, zinc HCl Clemmensen reduction fail for acid sensitive type of group. Okay, so it means that we are going to use the second kind of reduction. Yes, that is Wolff-Kissner reduction. And this is the point. That's why we're using two kind of reduction. That one is the Clemmensen reduction, and one is this that what we're just discussing now. That Wolff-Kissner. So Wolff-Kissner, Clemmensen, two kind of reduction now. So let's just start with the second kind of reduction there. Okay, so where's the slide? This okay, so let's talk about the next one, that is the Wolff-Kissner one. So how about the things that the condition like working everything is same. Oh, the O is going that simply combined with the two hydrogen there or replaced by the hydrogen. Reason this time basic, it's famous for the base. So which kind of base we're using? That is NH2 and NH2. Okay, anyone, do you know the name for this? NH2 NH2. Yes, Dashika, I guess you already NT already release a kind of PDF. Okay, just read it. Like this time, they remove 30 questions something. Okay, it means in the previous year, what is the point that we are able to attempt 25 question out of 30, but now that point already removed. Just because of new guidelines is there, because those guidelines just because the COVID there. Okay. Okay, Dishika. So what is the point of the mock if first of all let's finish the syllabus. Okay, and then you can solve the PYQ. Okay, just use some app like I guess some NT. Okay, there's some kind of app that is suggested by the NT and that the previous year available. Okay, then you can solve them and okay. Hydrogen. Yes, very good. That is the this tank. So yeah, you're right. That is hydrogen. This is our hydrogen. Okay, then? So let's see that how it is going to work. Okay, so now observe this point, everyone. Like there is some small point we have to identify so that we are build up our concept. What is the important key point? Do you know that if you are having a Cu bond and whenever you are observing any kind of nitrogen kind of molecule, okay, means not getting. For example, if let's suppose I'm having a carbon double bond, okay, and I'm using anything, okay, it's not like only this point. Maybe let's suppose I'm using RNH2. So what is the point number one? That nitrogen is going to combine with oxygen. It means what will be the product we are getting? That is like this. N, H and R. This kind of product we are getting here every time. Okay, so every nitrogen compound going to do this. And it's if I'm saying nitrogen compound, don't say I'm NO2, okay? No, NO2 no. Okay, so just try to understand my point. Anyway, let's use this hydrogen molecule and again how it is going to work, how it is going to attack. Okay, this is right now the not the topic of discussion. So in this case I'm using this hydrogen NH2 NH2 molecule. Okay, so what is happening, it is going to combine obviously, so we are getting carbon double bond and this N. Since everyone, I guess you already know that uh, in this case, so I have to use hydrogen or not? Am I right? I can use or not? Yes, please. Is it feasible I can use this or not? Okay, maybe you're not getting my question. Listen, my point. That we can't do, right? Because in this case, 1, 2, and 3, 3 bond total. Nitrogen, if there's a 4 bond, so definitely nitrogen achieve a positive charge. So that's why I remove this. It means this is the thing which is really formed here, okay? So this is the point number one. That CO hydrogen we are using. And in this case, the second step, we are going to use the QH. QH means any base, like naming reaction. So be noted, we can use any base here, but since this is a name of a reaction, that is a Wolff-Kissner reduction, naming reaction, so we can't change the reason. So in this case, we have to use the KOH is there. Okay, so KOH is there. KOH we are going to use. And then what is happening? What will be the next step there? That in this case, of course, the side product is really very much important. Okay, so like this is combined with hydrogen and plus N2 gas release here. Okay, N2 gas release here. So let's just back and let's try to observe the mechanism kind of thing. We are using H2 and this is KOH. Apart from KOH, like this is ethylene glycol we can use because we want base. Okay, OH simply or like water is like it's going to release. Okay, let me just back again. In this case, if you're observing something, let me highlight this. That is, this is a H2 there. Okay, and this is a OH there. So what is happening? That water molecule also release. So plus one more thing that water molecule also released there. So if this written, this negative sign kind of thing written on a this arrow, it means that it's going to release. Okay, and to guess release there, how it is achieved, how it, the mechanism. Okay, no, it's not the point of discussion right now, and it's not important for us. Okay, so that's it. This is the only point we are going to remember from there. If you want mechanism, how it is going to work, that OH came into the picture, attack on this, and like, okay, if you want, I can explain the mechanism to you. Okay, wait. Okay, for this part, I have to explain this here, how the reaction is going to work. So you will be having C, nitrogen, and NH2 there. Okay, like this. This is the extra point. Maybe it's not visible, right? Let's see on the next slide. This is the extra point. This is not important here. I'm only explaining for your understanding like how we are end up with this, okay? So what is this? That you are having a carbon double bond N and NH2 and this. So I am using KOH, it means OH negative, and OH is what? OH be like I am a base. I'm going to extract the more acidic hydrogen, okay? So in this case, that OH attack on this. Okay, let me just write two hydrogen be like this, one hydrogen like this. Okay, so what we are getting now, that is a carbon double bond nitrogen, and there's a negative charge generated on a nitrogen. Okay, so next step is what? This simply move here and this simply move here. So what is the next step? That is this carbon received a negative charge. Okay, and then double bond and like this nitrogen. Okay, so the second step is what? This hydrogen, wait, that the water molecule remove. Again, the water molecule came to the picture. It means if you have to use the water molecule one more time, H positive ion come. That H positive ion simply attack here. Okay, if this attack here, what is happening? This hydrogen remove and the nitrogen molecule going to relieve. Okay, so means what we are end up simply that carbon hydrogen, this extra hydrogen connected here. Okay, and this hydrogen simply again connect here. So one more hydrogen and plus that N2 gas release with the water as well. So if you are observing side product, this is the side product water, and this is the N2, and this the thing which we want. Extra point, no need to remember, just try to observe how the reaction is going on. Okay, the only important part for this one, that the direct reaction important. This is a direct reaction. Again, like this time I'm using base. Okay, so again this reaction has a limitation that we can't use the Wolff-Kissel reduction for the basic sensitive group. Like the previous one, acidic sensitive group, similarly that is for this one we can't use the base sensitive group. Okay, so this is how it is going to work. Okay, so let's continue further. And this is a very simple reaction. So let's see a kind of note for this, like what is written here. Due to the presence of basic, okay, the same thing written that you are using basic condition, okay, so we can't use the Wolff-Kissner for acid sensitive basic sensitive group like COH or Cl. For example, in this case, what is the point that this group have to be reduced, right? But what is the plus point? Chlorine is a acid sensitive group, and this is going to convert in the OH there. Okay, so why? Because it's a living group. Okay, so that's why it's going to leave. Maybe you are not getting, let me explain what is this. That OH attack here, chlorine leave. What does it? Substitution reaction is going to happen. Okay, so be noted that the term and condition apply. We can't use Wolff-Kissel reduction for acidic basic sensitive group, and then the previous one, the Clemmensen one, for acid sensitive group. This is really very much important part. Okay, that's it. This is all for the case. So I hope, okay, so that's it. This point is clear for everyone. So let me just back again toward where we're just starting all the thing. So, which slide? Wait a minute, okay. Oh yeah, here. So look at this. Two part is covered now. Now let's start with the last one, that is a Wittig reaction. So what is this Wittig reaction? Okay, so you can say in the organic chemistry, this is one of the easy reaction, that Wittig reaction. So what is this? Let's talk about this. So let me tell you again, mechanism is not important here. What is the important part for the Wittig reaction? That for the Wittig one, you will be using some R, and CO. Okay, and here the one point we are going to observe here, that is a new topic for you. What is that? That is a yelid. So where's the slide? Yeah, here. So look at this. First, let me just explain what is this, the meaning of this phosphorus halide. Okay, so it's nothing. Simple. There is a some carbon connected with some R group. Okay, they can be same, but they can be different R. And then there is a double bond with the phosphorus. Double bond with the phosphorus. Okay, same here, they can be different. Okay, it's not like maybe the hydrogen can be there. Okay, maybe that is this phosphorus may be connected with 2 CH3 group. Okay, any phosphine kind of thing can be connected here like this. Let me just back again that what is it? Look at this. Okay, like here we're using C6H5, and what is this? This is a kind of P. Okay, maybe you already know from the coordination chemistry. We are having pH3 as a ligand. We are using PR3 as a ligand. Okay, we are using PPH3 as a ligand, and we are using POCH3 as a ligand as well. Okay, so means phosphorus can like this thing can be replaced by hydrogen or R or pH and this. Important is what? That whenever the phosphorus combine with the carbon with a double bond, so this kind of arrangement, like Grignard region. So the name for this one, it's known as a yelid, phosphorus yelid. But again, what is the point? That in this case, phosphorus is a metal or a non-metal. It means I'm having a phosphorus or a carbon. So according to you, phosphorus have a positive charge or a negative charge? Yes, please answer this question. Yes, please answer this question. Between negative electron rich. No, no, no. Listen my point that if I'm having a phosphorus, so or a carbon, so which one got a negative charge or a positive charge? Okay. No, let me know the atom, like phosphorus positive. Okay, what do you want to explain? So I am assuming like you were saying positive for the phosphorus, right? That is the Kanaya and Niharika. Okay, Lakshmi. Okay, a general question. If I'm moving down a group, okay, so this is my carbon, and the next is going to be the sorry, silicon is there. Sorry, I'm so wait. Nitrogen, okay, and this is phosphorus, and this is silicon. So according to you, phosphorus is more electronegative or positive? You're wrong. Okay, not an issue. So who's going to be more electronegative? Carbon, right? Yes, Kanna, you're right. Okay, so don't say, ma'am, see, like along the period, isn't it the phosphorus is more? No, 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 no. Come on, it's the third period and they are the second period element. So be noted that in this case, phosphorus has a positive charge or a carbon has a negative charge. So this is the normal thing that you get. I already told you it can be different. Like this can be any kind of group. It's not the point of discussion right now. It's very simple thing. The next point, listen my point, that do you know phosphorus has a very good love for the oxygen as compared to the carbon. If you are having a phosphorus, you are having oxygen, so definitely phosphorus leave the carbon going to combine with the oxygen. Means, okay, so what is the meaning of this point? Let me explain the point or what is the Wittig reaction, that simply you are using a phosphorus halide, okay? So what is going to happen there? This is a phosphorus. Okay, let me just write there is some R and R. Okay, try to understand the mechanism and a double bond. Let's see, this is a CH3 or this is a CH3. I'm using some carbon double bond. Okay, let's see, this is some R and this is some R dash there. So phosphorus quickly combine a bond with this. So it means this, first of all, this is the point. Point number one. So in this case, phosphorus, sorry, that is a phosphorus double bond and RR part remove. Okay, and the second thing that you can say this one, this and this both combined with one another with a double bond. That's it. This is a Wittig reaction. So you can say carbon double bond carbon and a CH3. So it's very interesting, right? That means what is the point right now? What is the thing we are going to discuss? That this part and this part combine them, okay, and the center is going to remove. So this is known as a Wittig reaction. What is mechanism? Okay, for this one we are getting a four member intermediate. This is not the point here. Okay, this is not important part of this topic. Okay, Wittig reaction, that's it. Mechanism important, not, it's not important. Okay, so I hope that Wittig reaction is clear for everyone. Look at this, the salid part, phosphorus salid. And one more thing, that it can be E or it can be Z. Okay, for example, okay, just answer this question. Is it E or it is it Z? Okay, let me just change some R. Okay, let me just use some R value. It is a CH3 and it's a CH2 and a CH3. Okay, it's a OCS3. I just want to ask, like, is it Z or E? Okay. Yes, please. So this one, this given thing, is it Z or is it that E? Like, what is the meaning of this Z or E? Yes, please. Is it going to be Z or is it going to be E? Come on, it's a very simple question. Okay, Chinmay. Let's see. So first of all, listen everyone. What does this G? Z means cis, kind of thing. Okay. What does E? E means trans, right? E means trans, like in other term. But since in this case the group is not same, so we are going to give the priority. Priority we are going to choose here. So priority wise, both are carbon, but priority wise, according to CIP rule, this one has a first priority and this one achieve the second priority there. And out of this OCS3, the first atom is a carbon, the first atom is oxygen. So priority is said oxygen has a maximum atomic number. So this is a first priority, this is second priority. So same group, priority group, same side. So which kind of thing is it? Cis the kind of thing. It means G. This is G. Okay, be noted. Very good, Chinmay. Z there. Okay, so like this is how we're going to identify. It's really important part. If you don't know, again watch the reaction mechanism. Okay, like very bad. It's easy question according to me. Anyway, let's just back what we're discussing, that with integration. Okay, so it can be E or it can be Z. It's totally depend upon the choice. Like they can switch the position, E or like rotation also possible there. Okay, it can be changed. Okay, that's it. This is all for the Wittig reaction. Now let's solve a question. Okay, just answer this question. Yes, please answer this question. In the reaction scheme below, that Q, R, and then some S is there. First of all, this is a question for you. On the next slide, we will be having some options. Okay, so till then, take your time, like 30 second approximate, and then option part. Yeah, you can say. If you already solved, please just try to solve. Okay, if you already know the answer, don't let me know about your answer. But question is easy, okay? Take your time and okay. Like you have to identify if we are moving from P to Q, everyone, okay? If I'm moving from P to Q, so what is the first reaction? What is the first reaction we are given here? Okay, you know, like AlCl3 is a reagent, and I'm getting some kind of this COCr type. So, like which kind of reaction this is? So, whenever you're observing this AlCl3, the first thing strike in my mind that definitely it is going to be the electrophilic substitution reaction. Right, everyone? So, which kind of substitution this is? Options are like bromination, hallucination, sulfonation, nitration, Friedel-Crafts alkylation, Friedel-Crafts acylation. Okay, this is how we are going to select like every point, like determine conjugation. No, Shiva, it's not Getter-Minkoff reaction. For the Getter-Minkoff reaction, what is the point or what is the thing we're going to use there? That is a CuNHCl, if you remember. And what we are starting there, that we are just using a kind of benzene only. So if you're using benzene and this thing, we are going to end up with the benzaldehyde, okay? So it's not a Getter-Minkoff reaction. It's a Friedel-Crafts acylation. Okay, it is a Friedel-Crafts acylation reaction. Okay, this is the point number one, right? Why I'm explaining this question here, so that everything properly revised now. Okay, so it's B noted, it's a Gittenband acylation reaction. Sorry, I'm sorry, Friedel-Crafts acylation. Okay, Shiva. Okay, I hope you are done with the question. Now let's see the option part. Okay, these are the option. And since this is advanced question, MSQ question, okay, more than one option can be correct here. Okay, of course, my agent is not here. Like, I know question is a little bit scary, right? But still, just try to analyze. Don't worry, I will explain to you. Anyone wants to try, or then I have to explain? Okay, take your time, 1 minute, okay? Although it's already just 2 minutes. Okay, Lakshmi, not an issue. I will explain. But at least you have to try, right? Just think about it. Actually, what is going to happen? Okay. Okay, then. So let's continue then with the question. Okay, everyone. This is a molecule I'm having. Okay, let's just start with the step number one. Okay. See, that it's a very easy question. You'll be like, ma'am, you already know the answer. That's why you're saying easy. I know, but still. Okay. So in this case, the step number one, this. Okay, AlCl3. So let me just write the name of the reaction. It's a Friedel-Crafts acylation as we already discussed. Okay, so let me just quickly give you the brief that what is the Friedel-Crafts acylation. You are having some kind of benzene, if you remember. Okay, and then we're using some RCOL group there. You can use any group like ROR as well. So what is happening? That this part, basically this portion only, going to combine with benzene. It means COR is there. So this is my Friedel-Crafts acylation part. Okay, like small point. Now, but in this case, mom, it's not like that. So listen, actually how it is going to work, we have to search like, oh, we are having this kind of group. So isn't it the same like this OR or anhydride or SL group? So it means I know one thing, that obviously how the reaction is going to take place, that O is going to combine with the benzene ring. Now, but we have to decide. So I'm observing that only one, this is the portion where we're having a benzene, right? But now how to decide? Like ortho directing, para directing, meta directing, like how to decide? So let me just quickly highlight all the substituent on the benzene ring. Okay, so like all the substituent present on a benzene ring. So the point number one, this, okay, yellow, and then blue, and then this pink one. So according to you, like which one we have to select for deciding the position here? Anyone? What is the key point? If you're observing this is what it is going to apply. Shall I use hyperconjugation plus H? Am I right? Hyperconjugation? Pink one. Okay. Am I right? Hyperconjugation, right? Yes, Lakshmi, you said pink. So I can say hyperconjugation. Like residing factor plus M group or a plus H group or a plus I group or like minus I or a minus M or like minus H. Okay, you are right. Pink is the correct answer. But hyperconjugation is there or not? Yes, please. You think A and C? Okay, Niharika. Yes, please. It's a very basic question. Hyperconjugation is possible there or not? Yes. Oh, okay, very good, very good. So listen, listen, listen. Come on, look at this. This is a benzene there, group of interest. And what is it? It's the first number, first carbon. What is it? It's alpha carbon. There is any alpha hydrogen is there? No, zero alpha hydrogen. See that CH3 group connected here, CH3 group connected here, CH3 group connected there. How you can say the hyperconjugation is there? No, hyperconjugation is not there. Okay, Lakshmi? Okay, so be noted. It's not hyperconjugating group because alpha hydrogen is zero there. So hyperconjugation is not going to work. Only which thing is going to work here? That is the plus I effect. Okay, so like in this case, yeah, you're right. Although this is the deciding factor, but the deciding is plus I there. Okay. Anyway, the important is what ortho or para directing. So this is ortho and para directing. So search for ortho and para position. Look at this. This is my ortho position and this is my para position. Point number one. Okay. Now, wait for a while. I'm erasing, okay? Just try to observe this point and this point. Like which one we are going to select for deciding one. Okay, just for this, I'm explaining here. Look at this. This is a five-member ring. This is a benzene. Here, one, two. Two alpha hydrogen. Look at this. Here, zero alpha hydrogen. Okay, so it means now which is the deciding factor? This is the deciding factor, point number one. Okay, now maybe you will like, ma'am, why not this? With respect to this point, observe everyone. Again, this is a zero alpha hydrogen. Okay, so everyone, is this point clear for everyone? Who's the deciding factor? This is the deciding factor here. Okay, so this is the deciding point. It means this is the point who's going to decide like ortho position or para position or meta position. So let me just erase now. I hope this point is now clear. So with respect to this, what is the ortho position? This is the ortho position. This is the ortho position. This is the para position. Para is already occupied. Now between, let me just use some number. Okay, para is already occupied. This one you have to focus. Okay, I'm erasing this. I hope this point is now clear. Okay, it's not like that question is lengthy. Okay, I'm explaining every point, that's why it's lengthy. So A and B. So which position is feasible according to you? So I have to go with A or B. Yes, please. This question has so many concepts. A or B, which position is feasible here? B, very good. Okay, why not A? Because we already covered this thing so many times that in a single line, three group, so much hindrance, not possible. If we are having a choice, always try to observe this that no, it's not feasible. Only this side is possible. Okay. So anyway, after all discussion, I know one thing that this point is going to combine. Okay, this thing is going to combine with what? This benzene or this given that anhydride there. Okay, so let's see. Again, mechanism is not important, not important, and not important. So look at this, that how it is going to combine. This point simply connected here. Okay, and this bond open up. Okay, although like this is a two separation, but still what I want to explain here that you have to follow the normal mechanism, that if you're having a benzene and I'm adding some RCOL group, so what is the final product we are end up? That is the final product we are end up is this. Okay, that's it. How we are end up? Why? Okay, it's not important because we know the reaction already. So why we have to waste the time? Okay, so anyway, what is the point here? That this is a benzene, and every time when you are solving these kind of question, give some number. Why we are using some kind of number? So that the issue with the position is not there. Okay, so let me just write the number here. Let me just tag it. Look at this. This is a carbon number 1, carbon number 2, 3, 4, or 5. Total 5 atom is there. So let me just select. That is the benzene which is combined with CO group. Right? This group. This group. This is the point. CO group there. Because we are dealing with the acylation there. Okay then. 1 carbon. Okay. 2 carbon, 3 carbon, 4 carbon. Okay. 4 carbon total, and then here the CO part is connected, and this is my O negative there. Okay, so right now we are getting this. Okay, we are getting this. What is this? Normally acylation take place. If you want to check, let me just give number one more time. It's a 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5. And if you're observing this, okay, let me just erase the arrow. Okay, now observe this. Every number, same place. Yes, is it okay? Yes, this is okay. Okay, so first point is what we are simply unfollow the acylation part here. Okay, so let's just back again. What we're discussing, we are just getting a Q there. So let's just search in option Q, Q, Q. Q is this. Okay, don't say ma'am that you are using COH. Okay, let me just back here. Of course, in this case, that after the deprotonation step, the OH group is going to combine there. Okay, so this is our Q, which we want. This is our Q. Normally, this is our Q. So let me just back again. Observe this. QQ is what? That at this position, if you're observing this position, this group. Let's count numbering 1, 2, 3, 4, and then 5 total. Is it 5? Yes, it's 5. So like out of all the option, this is the correct answer here. Like B is the correct here. Just by using the point number 1. If this is Q, S or S, it means we are going to check between now S or S. Like the A is correct or the D is correct here. Okay, so let's just back again. Let me just start. Sorry, this is the slide, right? Observe this. So we are getting now Q there. Now in a Q, I'm going to use ZnHgCl there. Yes, please answer this question quickly. That what does this ZnHgCl is going to do? If I am using this ZnHz or HCl, we just discuss. What is the second point here? No, Dashika, it can't be para because para is already occupied. Okay, para is already blocked. Yes, very good, Shiva. It's going to be the Clemenson reaction there. Okay, Dashika, listen my point that with respect to this group, okay, this is the para position. So how it is going to attack on a para? Because para is already occupied position, Dashika. Okay, so that's why para is not going to combine. Yes, very good. So it means one more point. It's interesting, right? One more concept, right? Yes, please. This is CO. Okay, just for this part, I am going to use these numbers. Okay, yes, please. A or B. So in this case, this ZnHCl going to reduce A or B or both. Okay, I'm repeating one more time. That is, it is going to reduce A or B or both. Because we discussed that Clemenson reaction, C you have to be there. So yes, please. If you are smart enough, you are able to answer the question. Both. No. No, Lakshmi. What is the topic name? The reaction of both aldehyde and ketone. That at any single point I mentioned to you that I'm going to use the acid? No. Okay, so only B is going to combine. These are the small point. Okay, that's why I'm considering the question so that every point have to be clear at your end. Okay, Lakshmi. So only B, not acid. Either the aldehyde or ketone is going to combine. Okay, so that's why A omit. I'm erasing this. Okay, why? This part after Clemenson reduction. So wait, back here. It means we are using this isn't. But what is the use of this H3PO4? H3PO4 there. Okay, so in this case, what is happening with the H3PO4? There acid. So acid be like acid obviously searching for the more basic side there. Okay, now out of all the options, like all the cases, if I'm using this H3PO4 acid, right? So proton donor, this be like I am going to donate the proton, which be like, oh, I'm having a lone pair, I can do. I can combine with you. Okay then, so what is happening that in this case, okay, in this case hydrolysis have to be there like this, and there is a positive charge generated. There is a positive charge generated. So it's a single step reaction. Try to observe the mechanism. Okay, see this benzene attack here. Okay, this bond open up and this water molecule release. Okay, I know it's a little bit clear. Tree, wait for a while. Let me just write. This water molecule I have to mention like this. Okay, after the protonation. So this simply combine here. Okay, this bond open up. Good. Now let's see what will be the next point. This is a simple benzene again. Okay, so in this case, let's count the number. Okay, of course the number is important here. So numbering, which color, which color. Okay, so the 1, 2, 3, 4, 5, and total 6. It means at this position we are going to end up with a 6-member ring. Okay, and what will be the case? Let me just connect this like this, and 1, 2, and 3. Okay, see this. That let's count the numbering. 1, 2, 3, 4, 5, and 6. See this. 6 and 1 has a new bond. See this. 6 and 1 has a new bond, right? Got it? Okay. And this water molecule release, but in the 6th carbon, the O negative you have to be connected. So see this, at the 6th position, the O negative group have to be connected. Okay. Wait, I will change the position of the video. Okay, see this. That how it is going to observe. Okay, like this. This we are getting. Okay. Oh, I'm sorry. Oh, sorry. Water molecule is going to release, right? So that's why the double bond we are having. Okay, double bond. Right now we are getting this. What is this? Let's just back. This is this R. This is this R there. Okay. So what is this R? The R I'm representing. Okay, this is the R. R. Simple R. Next up, Grignard reagent. So what is the use of the Grignard reagent? Observe ketone. So what is the Grignard reagent going to do? If you are having OH and the CH3, remember the Grignard reagent. What is the function or what is the use of the Grignard reagent? Let me just explain this quickly separately. What is the function? If you are using some RCOR group and I'm using Grignard reagent, so what is happening? CH3 combine here alcohol. If you remember that we are under with the tertiary alcohol there, like look at the CH3. So that's it. Let's just back again. What we're discussing, the question. Here. So after using the Grignard reagent, what is the second point? That this thing is replaced by the O and CH3. Okay, don't worry, I will write here. Last step you will tell me, okay? It's going to be the easy one. So after the addition of Grignard reagent, OH and CH3. Yes, please. Next, we are using hydrolysis or the acid hydrolysis. What will be the next step? Last one, okay? Yes, please. Yeah, you are right. You are right, definitely, Shiva. That in this case, we are using acid at the end, so dehydration of alcohol, remember? So it means again the hydrolysis is there, it is going to leave, and we are end up with a double bond here simply, okay? That's it. So this is the final answer to the question. Let me just back again. What is S? So you are given the S, be like, no, it's not possible. So D is the correct answer here, okay? So D is the correct answer here. D is the correct, Q B is the correct. This is wrong and this is wrong. Okay, I know, very lengthy question. Let me just quickly give you a brief. First of all, that we have to decide the para or ortho. That first one is Friedel-Crafts alkylation. Then we are enough with this. Then with the help of ZnHG, we are going to reduce only the ketone part. So this is going to reduce. The next step, hydrolysis there, and then again attack, and we are end up with the ketone. Ketone is going to combine with Grignard reagent, then OH generated. Then if I'm using acid there, at the end dehydration there. So what is S? S is a dehydrating product. Any problem with the question, please quickly let me know. Okay. I hope every concept is now clear for you. But still any problem left? Let me know, please. And this is the answer. And this is the last step. Okay, so that's it. This is all for the point. Now, let's discuss about the second point here. Okay, what is the second point? Like, we are discussing like a sequence here. First of all, we covered about the nucleophilic addition reaction. Second point, we covered about Clemmensen reduction, Wolff-Kissner, or a Wittig reaction. Okay, now let's talk about some reducing agent. Okay, now the next topic is going to be the reduction to the alcohol. Okay, I guess no need to explain this. We already know this point. For example, that if I'm using a aldehyde, RCOH, okay, and in this case, if I want to convert into the alcohol, so I can use any kind of reducing agent. I can use lithium aluminum hydride, I can use NaBH4, even I can use like other reducing agent like diol H I can also use. Okay, so this is how we already covered, like if you are having aldehyde, we are going to get primary alcohol. If we are having a ketone, secondary alcohol. This part we already covered in alcohol chapter in very much detail if you want to understand. And but are the reducing agent, lithium aluminum hydride and the sodium borohydride. But now the new is what, that is catalytic hydrogenation. But this is also not very new topic for you, because we know what is catalytic hydrogenation. If you're using H2, platinum or nickel as a catalyst, so that's it, this is going to be the catalytic hydrogenation. But do you know what is the important point to be noted here? For example, what is the extra point in this catalytic hydrogenation? Okay, let's try to understand this point. Okay, observe there. For example, if let's suppose I'm having a carbon double bond, carbon, okay, and this is the COH group is connected. Wait, let's just discuss on the next slide. If let's suppose this is a CH2 and a double bond and a COH, okay. So in this case, I'm using lithium aluminum hydride. Question number one, like let's say this is A or B. So lithium aluminum hydride is going to reduce A or B or both. Yes, please. This lithium aluminum hydride going to reduce A or B or both. Okay, first point and the second point. If I'm using H2, PD, platinum or nickel. Yes, please. Then same. Both A or B or only A or only B? Both. Okay, Kanaya. Okay, one more reagent, okay? So that you can understand the point. NaBH4. Okay, so listen, actually, although lithium aluminum hydride is not going to reduce the double bond, but here, like this double bond in conjugation with the CO, so that's why it's going to work. Okay, so I will explain the point what I want to explain simply. So in this case, what is the point? What is the product we are getting? It is a CH3, CH, and a COH and H2 there. Okay, so this is the A, lithium aluminum hydride. How about the sodium borohydride? That double bond will maintain. Okay, it is not going to reduce with the help of the NaBH4. H2PD, you know, this one has a specialty. I am H2PD. What is my specialty? I am going to reduce the double bond. Okay, so in this case, that what is the extra point here, that everyone, you know, the main focus of the H2PD is going to attack on a double bond simply, and plus obviously this is also going to reduce there. Okay, so this is the extra point of using the P2 H2PD and platinum is there, that just to reduce the double bond. For example, I guess the lithium aluminum hydride explanation is not very clear for you. For example, okay, let's discuss about this. If I'm using lithium aluminum hydride now, so do you know this time this double bond will remain same. Okay, So you'll be like, ma, but the previous one you already reduces. But why not this? Because see, in this case, this is not active double bond. Active double bond means the double bond which is either in conjugation with the double bond. So in the previous one, okay, this is combined like conjugated with the double bond. It can be reduced, but it can't be reduced. But if you're using the same catalytic hydrogenation there, so what we are end up there that yeah, both is going to reduce there. So this is the final product. That's it. This is how we're going to select a different reagent. Okay, so let's just back what we're discussing. Not the slide. Okay, yes, please. So observe the catalytic hydrogenation there, that if you're using H2PD platinum there, so double bond OH, okay? Or if you're having a ketone, so we are end up with the secondary alcohol there. It's a repeated part of the previous class. Let me just quickly give you a brief about the reagent, like if you are having this, then how it is going to work. Let's just first talk about the H2PD. So double bond reduces, yes. CO reduces, yes. Ketone, yes. Ketone, aldehyde, double bond, all three is reduces by the H2, platinum, nickel, and platinum. Second of sodium, NaBH4 is there. So only aldehyde and ketone. Be noted that NaBH4 is not going to reduce this, is not going to reduce OR as well, because everyone you already know the function of the dibyl H. Dibyl H is famous for the reduction of the esters. Okay, so only aldehyde and ketone is going to work here. Acid? No, acid is also not reduces by the NaBH4 there. But now, you know, remember everyone that the AND game? Please add the video of the benzene intermediate reaction, the mechanism. Okay, so you can check it. I guess the video. Right now, I don't remember the session name. I'm sorry about this. Okay. Yes, please. What we're discussing? Yes, we're discussing about the end game, right? So you know that there is every time a villain there that destroy everything. So who's the villain there? If you know the villain name or you know the end game. Anyway, this is not that important here. Miss, out of all the reasons, that who's the main villain? That lithium aluminum hydride. So lithium aluminum, they like NaBH, I can't do this reaction. H2CPD, like I can't do this reaction. Okay, please teach the topic benzene intermediate. But that Kani, okay. So this thing we are going to discuss in the upcoming classes. That benzene mechanism, I guess you are saying, right? Benzene intermediate. Anyway, okay, so let's just back again what we're discussing, that lithium aluminum hydride. So this is really very much important topic. Okay, put 2 2 3 start. Aldehyde work. Ketone, it will work. If you are using ester, it will work. One more thing, be noted for the ester part, that this part, okay, this part is going to combine with the RDAS. Be noted, alcohol plus two type of alcohol will end up here. Next, that if you're using acid, it can do, because it's a strong reducing agent. Amide, be noted, this is important. If I'm using amide group, amide is going to convert it into the amine, not OH. Acyl group, OH. NO2 if you're using, this is the only reagent which also reduces the NO2 into the amine there. Again, like let me highlight the important part, because like some you already know that this is the important one. First, this is the important. Second, this is the important. And cyanide, and this is the important. If you recall dibyl H, everyone, if you recall the dibyl H, in the dibyl H, the same cyanide is going to convert into which aldehyde part there, but here it is NH2. So three things, that amide or nitro or a cyanide group. Okay, so all three is really much important here. Okay, so listen my point. What is actually your limb? But I call you the Kani. Okay, listen my point. That like specifically you just said benzene intermediate, but which specific topic you want in benzene intermediate? Like if benzene intermediate you are talking about addition or elimination reaction, like which thing? The complete one? Okay, let me know what you want. I will explain. Okay. any particular point or the complete mechanism. Okay, so let's back again here. So that's it. This is all for the reduction part here. Now let's see the next point, oxidation one. Okay, come on, we know the oxidation part already. That most strong oxidizing agent KMNO, HNO3, K2Cr27. Why I'm not explaining in very detail, because we already covered the even the mechanism of the KMNO for an osmium oxide, if you remember. HNO3, the strong oxidizing agent, K2Cr207, all are very strong oxidizing agent. It's not an issue if we are having aldehyde, right? Means issue means what? For example, if let's suppose I'm having a ROH group there and I'm using any oxidizing agent, at the end we are end up with the acid there, not an issue. But what if I'm using ketone there? Okay, my first question to everyone, that is it possible to oxidize the ketone to the acid? Okay, I will explain. Okay, yes, please, next class. If let's suppose today we are having a time, I will explain it then, okay? Yes, please. Is it possible to oxidize a ketone or not? So generally, no. Okay, no. Generally, no, it's not possible to oxidize a ketone. Ketone is not like aldehyde. Okay then. But what if I'm using a very strong, like we are forcing heat this, increase the temperature, we want to reduce, oxidize the acid, then it can do. Okay, so generally it can't do the reaction, but if you're using vigorous condition, obviously it is going to work. Okay then, sorted. It means, listen, it's really much important part here. One portion is this, okay? We are end up with this kind of acid, COH, and one portion is this R dash. So the second type of acid we are end up that are, okay, wait. I have to use some carbon, okay, so that you will get my point. That is a CH3, okay. Or the second one, that two carbon is there, so it's going to be the CH2 or a CH is there. But the point is what? Okay, the condition number one, like RCO. Okay, the condition number two, that ma'am, no, we don't like R with the CO. Why not? You can do. Okay, let me just use some R value. Mm, it is a CH2 or a CH2 or a CH3. Okay, let's suppose this is the group. So you'll be like, no, we have to go with this part here. Okay, maybe that is the COH part, like CO part connected with this. Okay, and the second one, like main point is what? Should I have to we have to connect the CO with this side or that side? Okay, not very clear. Wait. Let's see one more example, what I want to explain. That for example, let's suppose this is the molecule, okay? In this case, what is the condition number one? Condition number one, that the first acid is this, that CH3 COH. Okay? Second acid this, that CH3 and a COH is there. Okay? First point. Okay? First condition. Or the second point, that maybe that this CO combined here means what we are getting, COH, CH2 or a CH3. And simple, we are left with only one carbon, so it's going to convert into the formic acid like this. So means point is what? That should we to connect the CO with this part, or should we to connect the CO with this part? Right? That for unsymmetrical CO group, how to break the bond. This is the important point. Okay, so now a very much important rule is waiting for you. That is going to be the POPoff's rule. Okay, so what is the meaning of this word, that is POPoff's rule? Let's try to understand this. Chat is not working. Yes, please. Anyone, can you just type something? Because chat is not visible at my end. Okay then. So let's just see. Okay, continue. Okay, okay, Shiva. So yes, let's discuss about a new rule there. That is the pop-pops rule. Okay. So what is the pop-pops rule? So let's just back again here. Yes, observe this. The last line there. So observe this. The pop-pops rule said. Okay, pop-pops, pop-pops. Okay, which one you like, you can use. So in this case, the oxidation of this unsymmetrical alkene in such a way that the cleavage of the CO bond done that keto group is always connected with the small group, always connected with the small group. It's important. It means that the example we're discussing about the topic here, so which was the feasible one, like CO, the small group, it's a one carbon, and this side one and two carbon there. So which one is the smaller one? Obviously the one. So it means this is a feasible answer. These two are the not feasible answer. Okay, so this is all for the POPs rule that I'm repeating one more time. If I'm having unsymmetrical CO group, okay, so the CO is always stay with that group which is smaller in size. Sorry, small in number. Okay, let's solve a question, everyone. I hope the topic is clear. Let's solve a question. After that, the topic is very clear for you. So this is the question. Try to answer the question. Okay, so you have to identify the answer there. Okay, same answer. And obviously oxidation is there. So what is the answer? Only two option. Okay, just obviously I want to check it. The yes, please. Which one is the feasible answer here? No, no, both product are same. How? No, they are not same. Dishika. Okay, maybe it's looks same, similar. Like count the number of carbon, one and two carbon, and in this case one, two, three, and four carbon. In this case one, two, and three, and in this case one, two, and three. No product is different. Three and three, they're two and four. Okay, Dashika, they're different completely. Why not? Sorry, what do you want to ask? Actually, I'm not getting this. Previous question. Okay, wait, 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 wait. Please wait. Okay, so Lakshmi said B. Okay, B is going to be the correct answer. So rule said that is the CO group, go with the smaller one, right? So this side two carbon, this side three carbon. So you'll be like, I am to go with this. So which one is the feasible answer? B is the correct answer here. Okay, so let me just back. This is the question, right? So in this case, how it is same, Dashika? Look at this. The condition number two, that it's a COH, CH2, and a CH3. Okay, and this is COH is there, like HCHO. Okay, so both are a different group. Okay, is this point clear, Dashika? Yes, very good. Shiva, you also right. So different answer or different product. I hope it is clear now. So let's just observe this. That is the pop-ups rule. Okay, so let's just back again what we're discussing. Where's the slide? Done. Okay, so this is all for the question. Now let's talk about a question. Okay, this is a question for you. Answer this question, please. Last question. Okay, in the next class we are going to start with the tests, but this is the last question for the today's class. Okay, yes, please. Oh, Dashika. Mm, where's the slide? You know actually what is it? It's a formic acid, okay? This is a proper way to write it, this molecule. Okay, Dashika. So I hope that part is clear why I write HC which is there. Okay, I thought you already know that's why. I'm sorry I missed one hydrogen there. So let's back to the question. Yes, please. Means you have to identify. Oh wait. For this question, wait. I have to explain the tolerant test first of all. Wait, everyone. Okay, let's drop it. First, let's quickly discuss about the tolerant test. Okay, so everyone, now next class is going to be the test only, like Fehling test, Bredict test, tolerant test, Beer-Williger oxidation, and Hoffman reaction there. Hello form reaction. I'm sorry. Okay, so what is tolerant test? Everyone you know, silver mirror test. In this case, we are going to use silver ammonical nitrate solution. AzNO3 plus ammonium hydroxide or ammonia you can use tolerant test. What is the reason? Like what is the tolerant test? Who's going to use aldehyde? That if you want to oxidize the aldehyde, we are using toluene. How to? That with the ammonical silver nitrate solution, that AzNO3 combined with ammonia, ammonium hydroxide, it can be there. Ammonia you can directly use, just add some water in ammonia, we end up with ammonium hydroxide there. So in this case, basically we are end with a kind of complex there. Okay, a kind of complex. So let's see how it is going to work. This is a complex of AzNO3. This is a aldehyde. Toluene is an oxidizing agent. So itself reduce, yes. Observe Az is plus 1. Observe 0. What is it? Reduction. So AzNO3, sorry, or the toluene agent being like an oxidizing agent. Aldehyde convert into what? That is carboxylate ion or the carboxylic acid simply. Silver mirror test, why? Because if you have to run that test in a lab, there is a kind of silver mirror appear on a test tube, and hence the name of the test is a silver mirror. It is for the confirmation of the aldehyde. First point. Okay, and like ammonia and water molecule is the side product there. One more important point here, that both kind of aldehyde react with the toluene. Both kind of aldehyde you mean to say, like aliphatic or aromatic. Next, this is the topic as well, like aromatic is going to combine or only aliphatic. So be noted that toluene test is given by both aliphatic as well as aromatic aldehyde. Okay. Okay, so that's it. This is all for the silver mirror test. And now let's solve the question. Okay, a note for you. It is going to reduce, oxidize both aliphatic as well as aromatic there. Now answer the question, please. Because here we're going to use this AzNO3, right? Because if you're observing the option this, this, or this. And it's not advanced question, it's a main question. It means easy question. Okay, yes, please. Dishika, main point is not the number of product is same or not. Main point is what? That is how the CO is going to align. I know that they both have a 3 carbon in option number B, but try to understand Dishika. Okay, D. Anyone apart from Lakshmi? Also want to go with the option number D? A, P, C, O, D. Which one is the correct answer here? Okay, Dishtang. It's Doctor. Oh, I'm sorry. I thought it's Dishtang, but it's a Doctor Strange. Then who are you? Okay, Shiva. Okay, Niharika. Okay, it means everyone is option C, right? Hmm, not an issue. Okay, 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 Kanaya. Let's discuss about the question. Okay, everyone, you are saying option D is going to be the correct, right? Let's see, not an issue. So in this case, sorry, not D, C, right? I'm sorry, C, C. So in this case, look at this. First of all, this is a CO and a COH. Aldehyde, right? So basically, in the option number C, we are using Grignard reagent first. If I'm using Grignard reagent first, so in this case, observe this. This is a kind of ketone combined OH CS3 group connected here. This is kind of aldehyde, or you can say OH and CS3 group connected here, right? Okay, the next one we are using again the then AzNO3 solution. Now, can you just tell me if I'm using AzNO3 here, so now what is the use of this Az or ammonical nitrate solution, everyone? Yes, if you have to go with the option number C, that how? How we have to proceed with this? No, maybe Lakshmi, you're right. Okay, just wait. Yes, everyone. Option number C, Shiva, Niharik, and Kanaya. Because I know one thing surely that if I'm using AZNO3, I have to make sure that I have to start with the aldehyde. Aldehyde. Something strike in your mind? That what is the use of this AZNO3? We can't use the AZNO3 in between the reaction. Everyone be noted. That's why I'm explaining this the Tolan test to you. Okay, so in this case, only the in the very first we are having aldehyde. So maybe the option A can be the correct, or maybe option D can be the correct. B and C incorrect, definitely incorrect answer. Okay, this is how you to identify the answer for the organic chemistry question. Wrong. B and C is not the correct answer here. Okay, so let's go. AZNO3 solution I have to use, or the silver numerical nitrate solution we can use. Simply, if I'm using AZN twice, okay, N positive. Okay, if it is not visible, I'm really very sorry. I have to change this. It's this. Okay, so it means this will remain same O, and the what is going to happen there? Acid formation is there. Okay, so quickly form the carboxylic acid. Step number one. Okay, now let's go with the step number two there. Okay, let's go with the step number two. Like Lakshmi said, option D is going to be the correct answer, right? So Grignard reason. Okay, so this is a CH3 and Mz and Br. So listen my point. If we are using Grignard reagent and I'm using COH is there, do you know? Although in the alkyl phenol part we discuss about if I'm having acid, we can go with the Grignard reagent, but it's not the feasible reaction. What is the problem? You know, Grignard reagent be like, hey, I'm a metal, okay, and my carbon has a negative charge. It is behaving like a base. It is behaving like a base, and it is searching for the most acidic hydrogen. And what is this? Isn't it the carboxylic acid, the strong acid in the organic chemistry? Oh, it will be like, not, don't worry, Grignard reagent, I will give you the hydrogen because I'm acidic in nature. So Grignard reagent be like acid-base reaction. Then why I have to go with the alcohol phenomena? Because the important, the basic thing that every time in a chemistry, if you are having a choice, go with the acid-base reaction. So we can use, but the major product is not which we want. We can't use. We can't use the Grignard reagent for acid. So that's why just by using this basic point that we have to drop the option number D. No, it's not correct. Grignard reagent combined with ester, Grignard reagent combined with acyl fluid, Grignard reagent combined with ketone or aldehyde. But Grignard reagent has a problem with the carboxylic acid. It's a kind of reversible reaction, not feasible reaction. Yield is very bad, poor yield. So, omit. No, no, we can't use. So D is also not the correct answer. Okay, so then go with this like H. Okay, now this is interesting one. Anyone, what should the next step? What is this? How to proceed? Yes, please. If I'm using this H positive or the CH3OH, what is the function of this? One of the famous reaction, if you remember. We already covered this part as well in alcohol reaction, if you remember. Yes, please. Anyone? Very good. It's esterification. Okay, search for. Oh, so what does like our alcohol and acid is going to combine? So ester formation. Ester formation take place, right? So let's see what is going to happen now. Esterification there. So means that after that we are end up with this. Oh, sorry, I'm really very sorry. Habitually, I'm sorry. Okay, so it's a CO, and then the CO, and then oh, alcohol OCS3 is connected here. Okay, and now use the Grignard reagent. So Grignard reagent, what is the function of the Grignard reagent? CO. So first of all, convert this OH and a CH3. First part is sorted, and if you are having ester or anhydride or acyl chloride, so two time. You know the first step is what? First of all, the CH3 combine here, this molecule remove, right? First point, and then still we are end up with the CO, and one more time Grignard reagent is going to connect, so there's a two times CO because we are going to get the tertiary alcohol in this case. So is it matching? Yes, match. Okay, so what is the correct answer for the question? Option number A. Okay then, so is this point clear for everyone? Out of the screen. Okay, let me just adjust then. Wait then, okay, I will change. Okay, wait, Dashika. Okay, the last step I have to change. Anyway, I hope you got my point. I guess it's visible now. Yes, it's visible now. Okay, Dashika. So done. This is all for the question. Now your turn. Any problem? So please ask. Yes, please. Any problem with the session? This is all for the class. Okay. I hope topic is clear for you. And please revise the organic chemistry questions, all the PYQ, because just the only way to understand the organic chemistry is the question solving. Okay. That's it. Solve more question. Done. So thank you so much everyone for joining the class. Thank you so much for your time. Have a nice day everyone. Thank you.